Yeah, football matches in Europe recently, where the AI computer vision actually thought the bald head of the referee was a football, and throughout the match it actually tracked his head, and then the people actually watching TV could not actually enjoy the match actually, and this was also in news couple of just 2-3 years ago actually, right? So, and then remote, I think. No. Yeah. So I think you might have also seen a lot of examples of this car crashes safety, right? A lot of autonomous cars have been crashing. Even as recently as 2021, I think, especially when there are stationary objects, they have some issues. Also, late at night when there are these bright lights coming from ambulance and police vehicles, they get confused as well. So another example, this was actually a deep Obama that was done and was developed by white people actually, right? And this AI excessively lightened the face again. So again, there's a kind of bias based on who's actually building these models as well. And, yeah, another computer vision one I'll show you. So this one, this is actually about labeling the image based on what's in the picture, right? Airplanes, skyscrapers, bicycles, everything it got right. And guess what it basically labeled them wrongly, right? And company, I won't name it, but they had to issue a public apology in New York Times actually recently, right? So now this is an example I tried. You can try this too on Google Translate actually. So you say wo nurse hai, it says she's a nurse, right? And then you try another example. Yeah, you just try wo engineer hai, it will say he's an engineer. So I think there's a data imbalance possibly in the training of the model. So it automatically assumes that a nurse is a lady and an engineer is a guy actually, right? So just examples of how AI can be possible. And I mean, it's still the problem, it still continues, right? Even this day. So I think a little bit about data. What is causing? I think Joe today morning had a great session where he talked about garbage in, garbage out, right? So I think it's all about data. Data drives AI, and data is growing very fast. So here's a graph from Statista which shows that data is growing 35% every year. And if we can see by 2025, it's going to be 181 zettabytes, and zettabytes is 21 zeros actually, right? So that's a rapid growth of data. I mean, that's a good thing because it's also driving a lot of revenue. But at the same time, there is also energy consumption. So here, if you do air travel round trip New York to San Francisco and back, 1984 pounds of carbon dioxide is emitted, right? Car in the entire lifetime in the US, fuel car like a petrol car, 126,000 pounds of carbon dioxide it emits actually. Now you compare that to the deep learning, a regular deep learning application, that's going to emit about 78,000 pounds of carbon dioxide. And if you do a large language model, it's like 5 times the amount of the car's lifetime of carbon it belches out actually. So when you talk about, so look at what is the impact on the environment, because a lot of carbon is emitted because these large language models also they run in data centers which uses fossil fuels, water and whatnot, and there is a direct impact on the environment. And apart from the textbook definition of responsibility, we also have to look at the global south. So when you look at countries like India, for example, and when you're, let's say, building AI applications, there is also the angle of affordability. I mean, if you build it with the Western market in mind, you're getting a lot of people in these countries like Africa and Asia who won't be able to afford your AI actually, right? So the socioeconomic considerations of the user base is very important. Also, legacy infrastructure. I worked on a use case at Accenture a couple of years ago where we were building an application for an organization in India where they could not afford new infra. So we had to use like 15-year-old infra to still make the AI work actually. So these cameras were really old, but still we had to work with the data to make the inferencing work. And then of course data, real data versus proxy data. Many times capturing real data because of the sensors involved, right? For example, if you want to measure ammonia and water, it can be very expensive to get that sensor. So there are also things like heuristics that you can use where you derive data based on some other data which is easier to measure, and then you basically figure out proxy data versus real data considerations come in over here. And of course multilingual. In many countries, especially in India and Asia and places like that, it can't just be English, it has to be working on multiple languages as well. So these are just some of the affordability considerations from a perspective. So suboptimal data. We talked about irresponsible AI. We talked, and then before we talk about optimizing data, we'll also talk about how can data become suboptimal, right? I think multiple ways. One, there could be imbalance in data. For example, let's say you're training data for a translation model. We saw the nurse and the engineer example, right? There's possibly not enough male nurse examples in the data sample, so there could be data could be skewed, imbalanced. So model doesn't learn that way. Then there's toxic content. I think you might have known OpenAI that had hired a company in Africa to do actually data labeling for very offensive content. And I think that content was so offensive that actually those guys got depressed actually, right? And they just dropped the project actually, right? So even labeling has to be done very responsibly, because you're not just labeling good content, you're labeling very bad content, right? And that can mentally affect people. So this goes beyond engineering. It goes into things like socioeconomic aspect, mental aspects, and things like that as well, right? Bias in data, like for example, a lot of resumes, job descriptions, scripts, movie scripts, there were bias actually, right? Because there are certain roles and certain types which are actually biased in certain directions actually. So that's again an area of research where a lot of companies are looking at debiasing data, where they could take your data, identify your bias index, and then tell you how to debias it as well. Duplicates in data. Every time there's a duplicate in data, you're going to have extra storage, extra energy consumption. Then data sources. You also don't know what your sources are today actually, right? Because a lot of content today is generated by large language models. If you look at a lot of blogs, if you look at a lot of stories, even movies are being generated by large language models. So then new large language models that are being built up, that is crawling the pile of data on the internet, and that's actually building its own model. So it can become an echo chamber where one large language model emits some hallucination and some other large language model consumes that hallucination. So that could become a very vicious cycle that could cause actually, right? Excess data, less data. So we did an experiment with machine learning. We actually had built a deep learning network which gave accuracy of 94% or something. We wanted to move the needle from 94% to 97%. 3% increase in accuracy, but the amount of the energy used for 3% increase was disproportionately high. So in that case, we realized that the business really need 97%. Can it live with 94%? Then we stopped the model training 94%. So basically, you don't overdo the engineering, which could result in more unintended consequences. Less data is again a problem, because if you have less data, then your prediction may be wrong, and if your prediction, all the energy you spent in training the model, inferencing is wasted, and you need to come back and retrain it, which is again wasted energy. So these are all some examples of how data can be suboptimal when you're actually training your AI models. This is a typical machine learning life cycle. I think most of you will be aware of that, right? I think just a recap, and we'll bring in how optimization can be brought into everything, raw data to ELT, ETL that most of you as data engineers will be familiar with. Then of course you have a ML platform where once the model is built, you typically containerize it in Docker, the model artifacts. You have an inferencing endpoint, you have API gateways, and then you have end users with devices who are consuming all your inferences. And of course, there is human feedback going back into this model. This is a typical model feedback loop. And in the model's lifecycle, there are multiple opportunities which you can do to optimize this whole lifecycle actually. And now that was just a regular machine learning class. When it comes to generative AI, a few more additional complications come in. First complication is typically all the data pipelines that you've been building, they would be consuming data or they would be augmenting data. But now with generative AI, these data pipelines are also going to be generating new data. So you're not only consuming data, you're generating data. So you need to design your pipeline such a way it can handle both generation as echo chamber. We spoke about echo chamber, right? Because if LLM is consuming LLM's output itself as input, then it becomes a hallucination echo chamber, right? And you won't know the source of truth again there. So quality assurance definitely becomes very important here, because it's more important than your standard machine learning and deep learning type of applications. You also have fine tuning and adapting. I think this is also becoming very popular, where I may not want to build my own LLM. I also don't GPT just off the bat. I want to take a open source LLM. I want to fine tune it with my custom data. Then again, how do I fine tune it in the optimal manner? Are there some best practices with respect to how you design your prompts? There are context window sizes, input sizes, which can actually make your prompts more precise. so that in an energy efficient manner you can still get your business job done actually, right? NLP, there's lots of very serious transformer NLP come into play. So the way you actually deploy and basically scale NLP also changes with generative AI applications. And lastly, you're not talking scalar data. In your standard machine learning pipelines, you would be using scalar data, but here it's all vector data, and you will be actually working with vector databases, dense vectors. And so there's again a lot of optimization even with respect to vectors, like how do you cache your vectors, how do you optimally do similarity semantic search with vectors, how do you do things like RAG, retrieval augmented generation, those kind of things, right? How do you combine these things in the right way based on your business case? I think those become very important from a responsible AI perspective. So sorry, can I go back? Yeah, I can go to the the 8th slide. Yeah. So I think as a software architect, I think there is some important role for most of us. Traditionally, right, we were used to looking at AI from a model-centric AI perspective, and then in fact, more than a decade ago, I started doing NLP and machine learning. At that time, it was really about models, where we would actually do ensemble models and try out multiple different types of models to figure out which is the best model to do for a given task, and that would be the area where you would be spending most of the time. But I think now, I think the emphasis is gone from a model-centric AI to what we call as a data-centric AI. I think data-centric AI, what it means is that you essentially spend more time on data. You ensure that your data is actually your data quality is good. You actually detoxify your data, you debias your, you remove all the errors in the data, and curate the data before you feed it into the model. And even though the model architecture may not be, you don't have to try multiple different optimizations of model architecture. Even by working on the data level itself, you can significantly improve the inferencing quality of your models actually. And so I think as software architects, I think one of the big changes that we are also seeing is in the SDLC phase. Typically, we used to do requirements gathering from an application and use case perspective. But now what even I am doing from a data-centric requirements gathering, right? In terms of, okay, what is the source of the data? What are the lineage requirements of the data? What storage expectation, retention policies, all of those things. Because once those things are taken into consideration, then automatically the quality of the data improves, the quality of your model improves. So that becomes very important. So from a data-centric AI perspective, the training data, right? What is the source of the training data? How is the data labeled? How is it prepared? How is it deduplicated and hence made efficient? So that is one part of the consideration. Inferencing data, again, things like prompt engineering. How are you designing your prompts in an energy efficient manner? Are you reusing the prompts? Are you using prompt templates? Now, these are all capabilities you can get in new frameworks like LangChain, and I think Microsoft has released semantic kernel, and these are all fairly straightforward to use. Like you can play with all these things. They give you very easy, and even Amazon has got prompt registry, where if you're team members, you can actually share your prompts and reuse the prompts as well, right? And you can also do things like, for example, you can limit the size of the prompt, you can limit the size of your input tokens, output tokens, and all of this has a massive impact on the energy consumption and the quality, results quality as well. So that becomes very important from an inferencing data perspective. Data maintenance is also very important because, things like storage tiers, right? You may be storing data in hot tier and unnecessarily incurring cost as well as energy efficiencies, right? But if you are not using the data so frequently, you can move them to colder tiers. In fact, most cloud providers now give you that automatic monitoring of data angle, where they will see if the data is really needed so frequently to be accessed. If not, move it to the cold tier. And if suddenly the access increases, move it back to the hot tier. So that type of automated data movement policy, automated retention policy, as from a data requirements perspective, will make your whole data engineering much more optimal. And there are many more other optimization techniques. For example, one thing I'll highly recommend is there is something called well-architected frameworks. So Amazon has got, Google has got, most of these cloud vendors, they give you well-architected frameworks. So they give you best practices with respect to everything, right? The entire data pipeline, all the way from how do you optimally ingest data to how do you process the pipeline to how do you feed it to LLM. Those frameworks are worth looking at. you could also definitely look at things like serverless approaches. So especially now that you're running, I think a lot of the data engineering workloads that actually do the computation before you feed it to ML, I think serverless as well as managed, both serverless and managed service, it's significant. A lot of the optimization is done by the providers. And in serverless, you turn on and turn off the instances when not in use. So automatically you consume less resources, less cost, and it becomes more competitive. Then of course, there is something called carbon aware efficient computing. So carbon efficient computing is how do you minimize your CPU, memory, and your storage. But what is carbon aware? Carbon aware, there are APIs available now where you can check the intensity of the grid. So let's say your data center is in Mumbai. It's got that blue star for software rating, which basically gives you a star, just like your refrigerator and AC have star ratings. I think software also in Germany is star rating now. It tells you how efficient you've done the engineering in. So you throw a lot of compute, a lot of resources, and still make your engineering work. But as engineers, you don't really like that, right? You want to keep it lean and efficient. And so there is a lot of movement towards that, because it also directly impacts the environment actually. Another area that I'm really passionate about is frugal software engineering. And frugal software engineering is basically to make your software and data engineering, all of that work in resource constrained environments. So for example, if your software and IoT sensors and streaming data, if it can work in sub-Saharan Africa, or if it can work in rural India, then it will work even in a very developed part of the world, right? But what works in Texas may not work in Tamil Nadu by default actually, right? Because big imbalance in terms of availability of bandwidth, infrastructure, and all of that stuff actually. So frugal software engineering, you start in a constrained environment with lots of challenges, make it work here, and then make it markets actually, right? And we did a lot of that actually. We built a lot of innovations right here in India, and then we were able to easily apply it to other countries as well, because we see a lot of challenges here which helps us engineer better actually, right? And the other thing is with respect to green AI and sustainability. I think just like your non-functional requirements in software like performance, availability, scalability, I anticipate that green will also become an NFR. So as architects, you would want to consider that as one of the NFRs, and maybe it might be an NFR called responsible data, responsible. So eventually, just the way you do trade-off analysis, the classic architecture NFRs, this is also going to become one of the important NFRs going forward, I think. And of course, there's a couple of other interesting things coming along, right? Like for example, Edge AI is becoming pretty relevant. Quantum computing for data and AI, I think that's a future trend, I think, which is picking up pace, and another couple of years, we're going to see a lot of applications in that space as well. And I think human AI collaboration. So a lot of the large language model and some of the work that we are doing, at least from our company's perspective, we are also doing what RLHF, right? Reinforcement learning based, basically human feedback. So one is, you could actually do your inferencing against these models on the data, and then you could do some metrics. You could do the classic, confusion matrices. You can actually compare it with some ground truth data and things like that. But at the same time, you're seeing from a domain perspective, there's a lot of human expertise that gives a feedback loop back into the system. Then the reinforcement learning works better from a human feedback loop perspective. So these are some of the things that, see with respect to how the entire data engineering and data ops cycle is going to evolve over time. So that's pretty much it, right? And I think I'll just conclude my talk and open for questions. So yeah, one more slide, I think. Yeah. So essentially, I think we explored that, how AI can be irresponsible, how data itself can be completely garbage, and garbage in becomes garbage out. And then we looked at what are the different ways in which generative AI brings in applications in the MLOps lifecycle, and what are the different best practices that you can do at each stage of the lifecycle to make it much more responsible. So that's basically the gist of thing, but I'm happy to take any questions. And yep, good.
Yeah, so you mentioned it a couple of times in the third slide.
Yeah.
Yeah. Hi. Yeah. Third slide and sixth, and again the seventh, mentioned the consumption of energy.
Yeah.
Right?
Yeah.
Minimize them.
Correct.
So I understand on a company measure it, right?
Right.
But how do you ensure that on an individual scale?
Great question. Yeah, yeah. Good question. So there are actually there are two ways of doing that. There is one called estimation method. There is monitoring method. So you can't exactly measure, you can't see carbon fumes in your software application because your software is running, the coal is already burnt and it's already generated the electricity. But what we do is there are tools which measure your CPU, memory, storage usage. These are called proxy metrics. So the proxy metric you can actually see if the proxy metrics are improving, you can see by that much percentage your energy consumption also improves. And then there are also tools called like code carbon, which you can embed as a part of your workload. So it can actually, it has models to estimate how much CO2 your code is emitting actually. So it uses machine learning and it uses historical data and it gives you an idea of how much carbon is emitted. So it can be done either by real-time monitoring or by estimation.
I think the latter might be more effective because the former is, being subject by multiple. It's not purely indicative of your workload.
Yes, yes. So, in any case, I think what they say is the absolute value of carbon emission is not important, but the relative increase or decrease of the efficiency of the resource, that is more important, right? So even if I come up with the arbitrary scale saying that you're 1 out of 5 on carbon emission and tomorrow you're 6 or rather 4 out of 5 or 5 out of 5, then you move the needle that much on the sustainability perspective.
All things constant, this one has
exactly. And what we have seen from field deployments also, it is on the total cost of operations to the client as well, and it helps us sell the deals to customers more easily.
Thank you.
Hi, I think my question is around, I think third or fourth point.
Sure.
So currently there is two additional things that is kind of based for this practice. One is MLOps, and secondly, with the coming LLM, Gen AI, there is something called LLM Ops.
Yes.
Right.
Yes.
So what is the current gaps which can be implemented for responsible AI, green AI?
Yeah. Good question. Yeah. So you're right. I think, you're right. MLOps is something we all very familiar with. LLM Ops is a new thing. So as I say, in LLM, it's easy to create POCs and toys, but to actually productionize it, it's actually challenging, right? Because you have to first, I think, a lot of the best practices come from data. So I think data is a foundation on which everything is built. So even though a lot of these new come, I think data engineers will be very valuable because if you don't create the foundation, then it's impossible to build these applications. So I think the best place to optimize the data and clean the data is in the data engineering pipeline. Right from ingestion of the data to storing the data to processing the data, ETL, ELT, every step it can be optimized actually. Like for example, you may do a lot of cleanup even before you ingest the data. You may do ELT instead of ETL in the lake. I think today there was a good talk on Apache. So I think these are all different things that you can do at every stage, even before the data is fed into training the model. Because once the model is trained, like what our previous speaker was saying, you can't delete it. Once it's like a black box, right? Once it goes into the black box, there's no way to undo that. You'll have to retrain a new model, and that becomes very inefficient. So I think fix the problem, nip the problem at the bud, even before at the data engineering phase itself, then it becomes much easier actually.
Just one.
Yeah.
On top of this, is there any specific thing from the architecture point of view we must do CI/CD pipeline?
Yeah, absolutely. From a CI/CD pipeline, I think there are best practices, right? For example, you may have your dev servers, pre-prod servers, and then production servers, right? So the way you treat your dev pre-prod, you can have a very differential treatment from the way you treat your production thing, right? And so when you do production, you'll obviously be doing a lot of experiments, especially with even deciding which foundation model to use. For example, do I use Llama? Do I use, there are thousands of models now actually, right? All sizes. So, and I think so as part of CI/CD pipeline, quick experiments, very fast iterative experiments, where the architect needs to even decide which foundation model to use. That's the first thing. Second, I think, do I own GPT? Do I boost an existing one, or do I buy one from the market directly and use it? This is the second decision. So once these two decisions are out of the way, then you can look at prompting. How do you make your prompts more efficient? How do you reuse prompts? How do you optimize on the context windows? Those kind of things. So step by step, if you take the entire architecture flow. I think there was a diagram from Anderson in the previous talk we saw. So each step, I think you can actually optimize that way. But I think from a CI/CD pipeline, early experiments to even decide which model to use, and then which approach of architecting to use. I think if you choose those two things, that's very important from a CI/CD pipeline compared to ML ops, I think.
Thank you, Venkatesh. Any more questions? I guess we'll take. You want to take another one?
Yeah, there's one right. Come again. Yeah, absolutely. I think, see, most of our clients, they all have ESG targets, right? So they want to become carbon neutral by 2050, 20 goals actually. And so we help them towards those goals. We are not saying that just by doing this thing you'll become carbon neutral, because it's not just electricity, it's water is involved. There is so many other factors, right? And there's also embodied carbon. So your GPUs that NVIDIA makes and your laptops that are being manufactured in a factory, I mean, you can't control that carbon either, right? So, but yeah, clients do talk about that. And what we say is, whatever you do here, it will aid you in the journey and will make you look more greener from a reporting perspective. Actually, that's what we. Yeah, we do. So actually, a lot of the data centers, if Amazon and Google data centers, a lot of the Europe East data, basically the Scandinavian countries, right? We moved some workloads from UK to Ireland, and then from Germany to Scandinavia. 70-80% we got automatic drop in energy because they use a lot of hydro and solar energy regions actually. Yeah, definitely. I mean, especially certain regions in the countries, they're very. France is nuclear energy. So if you move it to a data center in France, you're going to be using nuclear energy, which is also very green, right? It doesn't do any carbon emission. So yeah, there are now APIs available which tell you, given the data center, what is its grid intensity. So you can, this information is publicly available now, and all cloud vendors also share this openly. So based on your data sovereignty requirements, you can do that. Like if your client says data can't go outside India, then you're restricted to only the carbon use within the country. Depending upon the sovereignty, you can move it to other countries as well. Definitely, yeah. Okay. But as a rule, we say that your model data, you keep it, your training data, you keep it close to the model's deployment, and inferencing data, you keep it close to the users, so that the amount of transmission of data is also minimized in the network, right? So.
Any more questions? I think we'll take it up after the event. Yeah. Thank you, Venkatesh. Yep. Up next, I think we have Ashwin.